Hello guys, welcome back again to another moment of our live tutorial. This is Uncle Sam and this is what I basically do here, trying to make being smart the new goal in town by breaking down mathematical concepts in a way that is very relatable. I welcome you once again by joining this particular live class. So for today's class, we're going to be looking into linear and quadratic equations in logarithm. Remember, this is the last aspect of logarithm that I'll be exploring before we move on to a new topic. And I'm sure if you've been following along that you've gained value. Now, before we get into this linear and quadratic equation in logarithm, we're first of all going to be examining a question that is under logarithm. And that question is this. Express this as express 6 raised to the power of 2t minus 4 equals to 2x in terms of logarithm. Now, if you see a question like this, what are you supposed to do? Now, let's get into it quickly. This is the highlight of what you have to do today. I'll show you how you can be able to express values or expressions or mathematical terms in this way, how you can be able to express it in terms of logarithm, which has to do with logarithm of your number to a base equals to what? The power. That is the basic idea. Remember, recall, the logarithm of a number b to a given base implies that the number is same thing as the base, which is a, raised to the power of what? C. So what logarithm is actually telling us about is we're trying to find a power in which the base will be raised to give us what? The exact value that we had originally. So in summary, logarithm is just another way of representing or expressing numbers. So thank you guys for coming on. With this in mind now, what are we going to do next? We are going to simplify this. We want to express it in terms of logarithm. So let me show you how we're going to do that. So if you have this kind of expression, the first thing I can do here is kind of simplify. So if I have 6 raised to the power of 2t minus 4 equals to 2x, what can I do here? Well, I can decide to just allow the 6 raised to the power of 2t to just be on the left hand side. So what do? I'll add positive 4 to both sides so that I can subtract or remove this negative word 4. So this becomes 6 raised to the power of 2t minus 4 plus 4. I'm adding 4 to both sides equals to 2x plus 4. So once we've gotten to this stage, this goes on to cancel this. And what we have remaining is 6 raised to the power of 2t is equal to 2x plus 4. This actually reminds me of something. Does it remind you of something? Now, in the general form of logarithm, remember what I just said earlier, that log of b to base a equals to c implies that the base, which is a raised to the power of c, the base a raised to the power of c will give me what? B. Now, if you look at this and look at this, it's quite similar. So for us to now express what this in logarithm form, what do? We simply state that, based on this knowledge, that actually that the log of 2x plus what? 4 to the base of 6, because here 6 is the base, 2t is the power, and this is the variable that if you raise 6 to the power of 2t, we don't know t, so we're not getting into how to find t. We don't know that. We're just trying to express this given in terms of logarithm. That's what we're trying to do. So once we have gotten to this point, t6 is the base. This is the variable that when you raise 6, which is the base, to a power of 2t, it gives you this. So expressing it in logarithm form gives us that log of 2x plus 4 to the base of 6 is equals to what? To t. So we have expressed this given term in terms of logarithm. That is what we're asked to do here. So this is it. So the intricacies of how to find x and how to find t to get the numerical value, we're not asked that. We're just asked to simplify this to give out in terms of logarithm. And I hope this is fun. Hope you get one or two from it. So let us now go into the main agenda that we have for today, which is linear and the quadratic equations in logarithm. So we're first going to be examining linear equations. So I'm going to clean this up, take a screenshot before I clean it up. I'm going to clean in 5, 4, 3, 2, and 1. Now remember that the basic idea of an equation is this. I keep mentioning this anytime I talk about any given equation. In mathematics, when we're talking about an equation, there are some ingredients that must be in place for something or an expression to be considered an equation. The first thing is the equality sign. There must be an equality sign. And another thing is that there must be a left-hand side and a right-hand side. For a given expression to be called an equation, you must have an equality sign, you must have a left-hand side expression and right-hand side expression. And then mathematically, equations are not just limited to algebra, because when we have expressions like, let's say 2x minus 3 equals to 10. Now this is an algebraic expression because we are having what? X, which is an unknown variable. But in math is not limited to just algebra. As simple as this is 2 plus 3 equals to 5, this is a mathematical equation. Why? Because a mathematical equation is simply a true statement. So 2 plus 3 equals to 5 is actually an equation because it is a true statement. 2 plus 3 is same thing as what? 5. So that's the basic idea. So once we've gotten to this stage, Arvin, hi! Welcome, Arvin. It's good to have you here, brother. Thank you so much for being here. Thank you. So let's continue. Now that we know the basic ingredients of an equation, which is the equality sign, the left and right hand side, and then it's not limited to algebraic expression, the next thing I'm going to be considering is how is linear equation. We're starting with linear equation before we go on to quadratic equation in logarithm. It's going to be interesting and fascinating. I'm going to tell you, it's going to be like a storytelling type of mathematics, so it's going to make sense to you. So you're going to become 1% smarter than you were before you joined this life. So let's get into it. I'm going to start with first an example. Let's look at this example together. So we have, if the log of 5x minus 4 to the base of 9, this equation that I have here, is equal to log 4 base 3. Find the value of x. Now, this is how you know that this is a linear equation. How? Because we are having what? This kind of expression here, which is 5x minus 4. And the variable here, which makes this an algebraic equation, x here, the power of x here, which is the unknown, is just raised to the power of 1. And that is what linear equation is about. It's also called simple equation. When you hear linear or simple equation, it's an expression that has an unknown variable that is raised to the power of 1, or that has 1 as its what? Highest power. How do you go about solving this problem? I'm going to use two approaches to solve this problem. And after using those two approaches, the one that suits you more, you can go ahead to use that. The first thing I'm going to do here is, the endpoint is for us to find x. That's what this equation requires us to do. So what is the first thing I can do here? Well, one thing you will notice in this given expression here, this is an equation. It is separated by an equality sign. It has a left and a right hand side. And by virtue, it's an algebraic equation because there is an unknown variable x there. That is it. Now, what you can see here clearly is that for this left and right hand side of this given expression, the bases are quite different. This is having a base of 9. This is having a base of 3. So it's already, looking like, what can I start doing at this point? They don't even have the same base. Well, there are provisions in the laws of logarithm that enables you to do a couple of things when the bases are not the same. So what is that I can do? We can decide to switch up the base of the left hand side. We can apply the change of base because that is part of the laws of logarithm. So solution, let's get right into it. Applying change of base to solve this particular question. And what I'm changing, where I'm focusing on, is on the left hand side. So I want to change left hand side to base 3. And now look at what is happening. For those that don't already know how the change of base system works, the change of base system works in the same in this way. If I have an expression where you have, in this case, log 5x minus 4 to the base 9, this is the expression that you have. I want to change the base of this expression now. What you simply do is the log will now be the numerator. The original 5x minus 4 will now be the log to the new base that you've changed to, then divided by the original base now have its own log, and then to the base that you changed to. So that's how it's done. So for this left hand side, this now becomes log of 5x minus 4 to the base of 3. Now remember that I've changed what? The base. The left hand side, I changed the base to become what? Base 3. And the reason why I did that is because the left hand side and the right hand side are not having the same base. So I decided to switch it off to base 3 because the right hand side is already in base 3. That's one of the ways you can solve this problem. After now, I'm going to teach you another way that you could have solved this. So let's go. So now that I've done this, divided, this is how you apply change of base system, divided by the log of 9. Remember, 9 was originally the base, but because I'm applying a change of base system, this is how or what it turns out to be. It now becomes a log divided by what? The log of the original base. You get the idea? So to the base of 3. Now you see that both of them are now in what? Base 3. I've changed it to base 3. Equals to log 4 base 3. Now, what can we do here? Well, I can simplify this 9 to become 3 squared. So this is something like saying the log of 5x minus 4 all over log of 3 squared to the base of 3 equal to log 4 base 3. This is where I am right now. Well, what can I still do? I don't want to touch this here. I don't want to touch this here. I can still do something here. Well, it turns out that when you have this under the power law of logarithm, that when the log has a power, it's okay to take the power and it becomes the coefficient of the log. So continuing here, we're now going to have that this becomes the log of 5x minus 4 all over, take the power, let it become what? The coefficient. 2 log 3 base 3 equals to log 4 base 3. And then you apply another rule or law in logarithm that states that if I have a logarithm that has the same value as its base, is equals to 1. So that implies that if I have log a base a is equals to 1. So if I have, this looks exactly like this law, it's part of the laws of logarithm. So I'll switch up these to become what? 1. So that 2 multiply that 1 is going to give me 2. So it implies that what I have now is that log 5x minus 4 base 3 all over the endpoint here is 2 is now equals to what? 2 log 4 base 3. Now we're getting somewhere. What can we do? Oh, no, sorry, not 2. It's just equal to log 4 base 3. Sorry about that. It's just equal to log 4 base 3, no 2 yet. Okay? So what am I going to do here? Well, I can decide to simplify here by applying cross multiplication or simply multiplying both sides by what? 2. If I multiply this side by 2 and multiply this side by 2, I'll end up that the 2 will cancel out. But the same thing as saying cross and multiplication. It's faster for me. I like using that. So you can actually imply that. So if you cross and multiply, this log 4 base 3 has a denominator of 1. If it goes to multiply, this gives you log 5x minus 4 base 3 equals to, if 2 goes and multiply this log 4 base 3, it's now going to give you what? 2 log 4 base 3. It becomes the coefficient of the log. So what can I do here? Now look at something interesting that we're going to do here, because if you look at this so far, it doesn't look like it's leading us somewhere, but it actually is. All the simple steps that we've been taking is leading us somewhere that is very, very crucial. So let's get to it. What have we achieved at this point? We've been able to simplify and we've gotten to this stage. Now what can we do? Remember what we did at this point, where if we have 2 or have a power, if the log is having a power, it goes, there's an avenue in logarithm or in the laws of logarithm that says you should take the power and it becomes the coefficient of the log. Well, we could actually apply that here, but here we're doing the reverse. Since you know that if you have a coefficient to the log, or if the log has a coefficient, that coefficient is seen as the power of the log. So we can switch up here. So this becomes log 5x minus 4 base 3 is equals to log 4 squared base 3. So I've reverted the process. Now that I've gotten to this point, we know what is 4 squared. 4 squared is same thing as 16. So I'm going to clean up here to continue. Going to clean up here to continue. Now that I've gotten to this stage, this implies that we have log 5x minus 4 base 3 is equals to log 4 squared now is going to give us 16 base 3. Now, you know this law that we apply in this. Something like, if I have 3 raised power of x equals to 3 raised power of 2. What we simply say is this: since the bases are the same, it simply means that the powers must be the same. I will now imply that x is equals to what? 2. Yes, because the base was on the left hand side in terms of the base is what's on the right hand side. And so that simply means that what? The powers will be the same thing. Well, we're going to be applying that here. What are we going to do? We're going to simply say that since the logs or the base of the log are the same, since the base of the logs are the same, which is why we have to do a change of base so that we'll have a correspondence with the base on the left and the base on the right hand side. So since the bases of each of the logs on each side are the same, it implies that their logs must be the same thing. So this implies, this is what you have. You don't need to write all this down, but you know this is actually what is going on. So this implies that 5x minus 4 is equal to 16. Since the base of the logs are the same, it simply means that the logs themselves must be what? Equal. So if that is the case, you go on to simplify. So this becomes like your 5x. You now add 4 to both sides to clear this negative 4. Minus 4 plus 4 equals to 16 plus 4. We added 4 to both sides. So this clears out, and you have 5x equals to 16 plus 4 will give us what? 20. And then we've gotten 20. What next can we do? We can divide both sides by the coefficient of x, which is 5, because we're asked to find x. So if you divide it by after your x is equal to 4. This is what we have here. X is equal to 4. Now this is what we have. So we've gotten the value of our x to be equal to 4. Now, this is it. This is our what we've arrived at. Now, this is the first approach. I'm going to give you another approach that we could have used to solve this particular equation, which is actually way more faster than this. So, are you ready? Let's get to it. Let's get to it, guys. So I'm going to clean this up. If you want to take a screenshot, please take a screenshot. And if you have any question at any point, please leave it in the comments. I'd love to hear what you think. And also, where are you connecting from, guys? Please let me know in the comment section. I'm connecting from Nigeria. Yeah, western part of Africa, Nigeria. So where are you connecting from? Let me hear your own thoughts in the comment section. I'm going to clean this up now. Please tell me where you're connecting from, so we can connect. Thank you so much, guys, for being here. So now we're going to use another method to solve this. You see that this one is going to be faster, and this is going to add to your knowledge about logarithm. So let's get to it. Please, guys, I'm still waiting for you. Please tell me where you're connecting from in the comment section. I'd love to know. Thank you. So what can we do here? The second approach is this. Since we have that log 5x minus 4 to the base of 9 is equal to log 4 base 3. When we treated the laws of logarithm, I took time to actually expand on those laws, why they are logical, or why they are, or the proof to these laws. We did an extensive lesson on them. You can find the videos on my live section of this page, where I did introduction to logarithm and the subsequent video. Once you finish watching that, you have a clear picture of what these laws are about and how to go about it, how to go about any given expression. But the key thing I want to highlight here is this. If there's an avenue, or if there's a given logarithm expression that, let me just use this example to explain. If I have a logarithm expression, log a, and then base b to the power of c. Now, the one that we're used to is the log being the one that has the power, where we take the power and it becomes the coefficient of the log. But what if the base is one that has power? Don't you think that is also applicable? Well, turns out there is something we can do about that. So this kind of expression where the base can either be reduced to a power or already came with a power, what can we do? It is simple as well. The inverse or the reciprocal of the power multiplied to the log of a to the power of b. So this works if the base already has a power or it can be reduced to a base and a power. That is how it works. So once you've gotten to this stage now, take note of this because that's what we're going to be applying here. I told you this is a shortcut of solving this and I love this particular approach. So what can we do here? Well, we can reduce this to become log 5x minus 4 to the base of 9 is simple as 3 squared. So you see now that the base did not originally come with a power, but it could be reduced based on requirement because we are looking at the right hand side and it's looking at something that we can reduce to so that both of them can have the same base. So once we've gotten to this stage, equals to log 4 base 3. What else can we do here? Apply this law that I just stated. Since the base is having a power, it's not going to be what? The coefficient. It's not going to become coefficient of the log, but it's going to be the reciprocal of this word, this value. So this is simple as 1 over 2 log 5x minus 4 base 3 equals to log 4 base 3. So now that we've gotten to this stage, what can we do? Well, what can we do? We can decide to multiply 2 to both sides, just like we did when we used the previous approach. If we multiply 2 to both sides, it's going to be 2 will multiply 1 over 2 log 5x minus 4 base 3. And the 2 will now go and multiply log 4 base 3. That's what we're going to have. And once we've gotten to this stage, let me continue here. Once we've gotten to this stage, it's now going to give us 2 multiply half will cancel out. What we have remaining is just log 5x minus 4 base 3 equal to 2 multiply log 4 base 3 is going to give us 2 log 4 base 3. And then we can now apply that same law in logarithm, the power law, which is that if we have log a raised to the power of b base c, the power can be able to become the coefficient, so it becomes b log what? A base c. So this is what we have here. We want to represent this now in this way because they are both the same thing. So once we've done that, this is now going to give us with log 5x minus 4 to the base of 3 equals to log 4 squared base 3, which is now going to give us log 5x minus 4 base 3 equals to log 16 base 3. I'm taking my time to break it down. There's some steps that you could skip if you were maybe writing an exam on this particular topic, but I'm trying to break it down to see for you to see the whole picture of what is going on here. Now that I'm to this stage now, since the base of the logs are the same, it simply means that the log themselves are equal. The base of the log are equal, log base 3 here, base 3 here. It simply means that the logs are also equal. So simply implies that 5x minus 4 is equals to 16. If you add 4 to both sides, it becomes 5x minus 4 plus 4 equals to 16 plus 4. So this clears out this. You have that 5x is equals to 16 plus 4 will give us 20. And implies, let me finish up here. And this implies that 5x is equals to 20. And if we divide both sides by the coefficient of x, see that your x is equals to 4. So you see that we got 4 that we had originally with the first method. And then the highlight from this particular second approach or shortcut that we use is to tell you that when a base can be reduced or already has a power, it's same as pushing the power to become the coefficient of the log and it becomes the reciprocal of the power. So that's the highlight of what we did here. So take note of that. I'm going to continue to solve another question related to this. Let's solve another question. let's solve another question, and then we proceed to quadratics. Okay. Okay, let me clean the board. Let's clear the board. If 1/2 log y minus 5 to the base of 3 is equal to x, find the value of x. Sorry, find the value of y. Of y in terms of x. Yeah. Terms of x. So let's go and solve this problem together. If 1/2 log y minus 5 to the base of 3 is equals to x, what is the value of y? Well, what are the things that we could do in this particular question? Let me write it down. 1/2 log y minus 5 to the base of 3 equals to x. And one thing I know is whenever there is a coefficient to the log, a number or any value close to the log, that value is something as a power of the log. So if I push this 1/2, it's something as saying the log of y minus 5 raised to the power of 1/2 to the base of 3 is equals to what? X. Yes, this is what it simply means. Now, this is now giving us something very, very interesting because it's looking like the general form of logarithm. Where we have that if log a to the base of b equals to c. What does this mean? It simply means that what our a is equals to what? B raised to the power of c. So this is the thing that we need to do to be able to what? Find our y. So this implies that if this is equals to this, it implies that y minus 5 raised to the power of 1/2. Yes, we're expressing it in the general form of logarithm. This is the basic idea of logarithm. I keep mentioning it. That if you have the log of any number to a given base is equals to c. What it simply means is that the log, which is a, is something as well the base raised to the power of whatever is on the right hand side. In this case, c. That is what is give us the equivalent of what this a. Example, if I have log 8 base 2 equals to 3. What it simply means that 8 is same thing as what? 2, which is the base raised to the power of 3. Connect the dot. That is the basic idea that we're trying to pass here. So here it simply means that y minus 5 raised to the power of 1/2 is same thing as the base raised to the power of what? X. That is what it simply means here. So once we've gotten to this stage now, well, what can we do? We can square both sides. Yes, square both sides. Because we're looking for y, not y minus 5 raised to the power of 1/2. We're looking for y. So if we square both sides, it's going to be y minus 5 raised to the power of 1/2, then squared equals to 3 raised to the power of x squared. So what are we going to do here? This square will go and cancel what? This 2 here. This half here. 2 multiply half is going to give us 1. So it's something as that will have y minus 5 on the left hand side. That's what we have remaining. And then on the right hand side, this is something as when you have an enormous power and an outermost power, according to the law of indices, they both multiply themselves. So this is something as what? 3 raised to the power of 2x. And now we can make y subject of the formula by what? Adding what? 5 to both sides. Add 5 to both sides. If you add 5 to both sides, it's going to give us y minus 5 plus 5 equals to 3 raised to the power of 2x plus 5. This clears out. It now implies that our y is equals to 3 raised to the power of 2x plus 5. Voila! We solved it. We've expressed what? We found the value of y in terms of what? X. We've expressed y in terms of what? X. So this is how to simplify it, and isn't it very beautiful? No. Isn't this beautiful? I hope you gained it now too. So now we're entering into, we've discussed linear equation. This is all about it on linear equation. Every other thing is still the same process. Simplify. Most of the times you are mostly applying change of base and the other things. So just the laws that are applicable. So you do the necessary conversions and simplification, and then you find the unknown variable. So we're going into the quadratic aspect of logarithm. So let's get into it. I'm going to clean this in 5, 4, 3, 2, and 1. So I'm going to clean this up. I'm going to look at least 2 questions on the quadratic aspect of logarithm. So what's the first question that we're going to be looking at? Here it is. Solve log x base 6 plus log x minus 5 base 6 equal to 2. Yes, this is what we have. Solve log x base 6 plus log x minus 5 base 6 equal to 2. This can be put in a bracket to actually separate it. Solution, I'll write it out. Log x base 6 plus log x minus 5 base 6 equals to 2. What can we do here? Well, we can start by applying the basic laws of logarithm, where if you have addition sign and the base of the 2 logs are the same, they turn to multiplication. Pick one of the base, which is same thing as log to the base of 6, because the 2 bases are the same. Pick one of it. Then open the bracket. This addition changes to multiplication, and the logs multiply themselves. So this is same as saying x multiplied with x minus 5. So the bracket here shows you that there is an invisible multiplication sign here, equal to 2. Well, another thing that we need to look at here is, let's continue first. So this is simple as log to the base of 6, open bracket, x squared. X times x is x times negative 5 will give us negative 5x equals to 2. Is this where it ends? Actually, no. We need to do something to this right hand side. What is 2? Is there a way that we can have, or we can express 2 here in terms of a log to a base? Or what log to a base will give us 2? So it turns out that 2 is same thing as the log of 36 base 6. How did I know? Well, I'm just trying to key in to the base that is already here. The base here is already 6. So I'm trying to tell myself, okay, what number will I raise 6 to give me 36, so that when I do the necessary conversion or simplification in logarithm, it will give me 2. So this is what it simply means, because if you switch this, it's same thing as what? The log of what? 36 is same thing as 6 squared to the base of 6, which if you apply the basic law of logarithm, the power law, it becomes the coefficient. So this becomes 2 log 6 base 6, and log of anything to its base is equals to 1. 2 times 1 is equals to 2. So C is genuinely how this 2 was gotten. So now that we know this, what can we do? I'm not going to replace this 2 with what? Log 36 base 6. So this is simple as log of x squared minus 5x to the base of 6 is equals to log 36 base 6. This and this mean the same thing, because 2 as a number can be expressed in logarithm as what? This, based on the given base. Okay, remember, logarithm is just ways of expressing values or numbers. Now that we've gotten to this extent, we do something very, very interesting that we did in the previous example, which has to do with when the base of the logs on both sides are the same. It simply means that their logs are the same. So if on the left hand side you're having a base of 6, on the right hand side you're having a base of 6 as well. So it simply means that their logs must be the same, which implies that x squared minus 5x is equal to what? 36. That's what it implies. And then it's looking like something interesting. So at this point now, we can decide to what? Take this what? 36 and move it over to this left hand side, or subtract 36 from both sides. So if you subtract 36 from both sides, simple as saying x squared minus 5x minus 36, or subtracted 36 from the left hand side, equals to 36 minus 36. And that will give us x squared minus 5x minus 36 equal to 0. Properly, ladies and gentlemen, we now have a quadratic equation. And how did we get to this point? From here, from logarithm, literally. So we can now go on and solve this the quadratic way, which are about 4 methods: the graphical method, the factorization method, completing the square, and the quadratic formula. So for this particular one, I'm going to be using factorization because it's quite applicable here. Now that I've gotten to this point, how do you apply the factorization approach to solving quadratic equation? It's quite simple. Take the first term here and last term, multiply them together. So it's same as x squared multiply negative 36. That will give us negative 36x squared. Now find two factors of negative 36x squared. Find two factors. So that if you multiply those two factors together, it will give you negative 36. If you add or subtract these factors together, it will give you negative 5x. Well, this is supposed to give us negative 9x and what? 4x. Why? Because if you multiply this together, negative 9x multiplied to 4x will give us negative 36 what? X squared, which you have here. And then negative 9x plus 4x will give us what? Negative 5x. So what am I trying to achieve with this? I'm going to replace this what? Negative 5x with these two factors that I've found. That's the basic idea of solving factorization using quadratic equation, quadratic approach. So once I've gotten to this extent, what I'm going to do is replace here becomes x squared minus 9x plus 4x minus 36 equal to 0. So you see that if I go and simplify this, it will still give me back negative 5x. So what do we do next? Well, we're getting closer to the end. Now that I've separated these, the main reason is to be able to factorize in parts. So here, I'm factorizing these two parts and I'm factorizing these two parts. So what do? What is common here on these two parts that I put a bracket on? X. Bring down x. Use x and divide each of the term. X divide x will leave you with just x. X divides minus 9x will give you with minus 9. So if you use x to multiply back, you still get back what you had originally. Then plus, what is common here? What can be factored out? Well, 4 is here, and I can also use 4 to divide 36. So it seems that 4 is common. So bring out 4. Open a bracket. 4 divide 4x, leave you with x. 4 divide negative 36 will leave you with what? Negative 9 equal to 0. So I'm going to clean up here to continue. Now that we've gotten to this point, we're now going to put, see that this and this are the same. Put this x plus 4 in the bracket. Simply implies that x plus 4 and the x minus 9, just pick one of these, is equal to 0. So if this, and you know that there's an invisible multiplication sign here, if this expression multiplied to this expression is equal to 0, it can mean one thing. It's either this side is equal to 0, here is equal to 0, or here is equal to 0. If a times z equals to 0, it simply means that a is either 0 or b is 0. So if a is equal to, let's say, 1, and then b is equal to 0, that will still give me 0. So that's the basic idea. So once we get to this point, we do something interesting, which we usually do in factorization and quadratic equation. Since this and this multiplied with each other gives you is equal to 0, it implies that x plus 4 is equal to 0, or that x minus 9 equals to 0, so that this statement will be satisfied. One of them must be equal to 0. So if that is the case, now we've broken it down. The reason we do that is to break it down into linear expression. Okay? Now that we have this point, so subtract 4 from both sides here. X plus 4 minus 4 equals to 0 minus 4. Or this side, x minus 9. Here you're going to add 4 to both sides. We're trying to make x here, which is the variable, alone. So to make x here to be alone, you have to add 9 to both sides. X minus 9 plus 9 equals to 0 plus 9. Implies this squares up that x is equal to what? Negative 4, or that x is equal to what? 9. So this implies that x is equal to what? Negative 4 or 9. So this given expression here, there are two variables that will satisfy, there are two values that will satisfy this expression to be equal to 2. That is, when you solve this left hand side of this expression, and when you solve it, or when you substitute x here to be either negative 4 or what? 9, it's going to solve and it's going to give you what? 2. So that's what it simply is. But the negative aspect is going to be Yeah. So that's the basic idea. We found our x to be negative 4 or 9. So one more question before we call it a day. One more question. Please take a screenshot. Take a screenshot. Take a screenshot. All right. Let's go on and solve one more question. On indices, sorry, logarithm involving quadratic equation. Let's solve one more question under these. Solve log to the base of 9 and then x squared plus 7x plus 15 equal to 1 over 2. Solution. How do we solve these? Well, I can start by doing something to this right hand side because here is already set. So I need to find a way to express this 1 over 2 in terms of logarithm where the base is 9 and then to a log of something. So how do I possibly do that? Well, it turns out that 1 over 2, how do I express 1 over 2 in terms of base 9? Yeah? Or what is equivalent when 9 is raised to the power of half? So if 9 is raised to the power of what? Half, is same thing as what? The square root of 9 going to give us 3. That means 3 is the log. Yes, 3 is the log. Why did I choose base 9? Because we want it to correspond with what is on the left hand side. And that's why we choose base 9 here. So what I'm going to do here, I'm going to replace this right hand side to become log to the base of 9, open bracket, x squared plus 7x plus 15 equals to log 3 base 9. Now, solve log 3 base 9. Does it give you 1 over 2? It actually does. Because this is something that's saying log 3 to the base of 9. 9 is something as 3 squared. So this is something as log of 3 to the base of 3 squared. And remember, one of the laws that we mentioned when we started off this class is that when you have a base that has a power, the base will now come and become the coefficient of the log, but it's going to be the reciprocal. So this is something as 1 over what? 2 log what? 3 base 3, which log of anything to its base is equal to 1. So this is something as 1 over 2 times 1, and that will give us what? 1 over 2. So you see that this is very logical. So now that we've gotten to this point, what are we going to do? We apply the same rule. Since the bases of the logs are the same, it simply means that their logs are the same. So this implies that x squared plus 7x plus 15 is equal to 3. Yes, the bases are the same, the logs must be the same. And so what we do, subtract 3 from both sides, so that here will now become equal to 0. That's it. Good. X squared plus 7x plus 15 minus 3 equals to 3 minus 3. Now that we've gotten to this extent, this gives us x squared plus 7x plus 12 is equals to 0. We now have a quadratic equation. Let us get right there into it and solve. So now let's solve it. I'm still going to use factorization method, although there are other methods that you can use. Maybe I can use quadratic formula. Let's using quadratic formula to solve. Let's use quadratic formula. And quadratic formula tells us that x squared x is equals to negative b plus or minus square root of b squared minus 4ac all over 2a. Now, how do we get this value of a, b, and c? Because we don't have it here. Now, it turns out that we have a prototype for quadratic formula. We have ax squared plus bx plus c. Your a is the coefficient of what? The highest exponent. The variable with the highest exponent, which is what? Square. The one that has square for a given quadratic equation. And then your b is the coefficient of the next one. And then c is the constant. So we can find that here. So what is the coefficient of this x squared here? It is 1. So here, our a is equal to 1. What is the coefficient of what? Our x here, which is the same thing as your bx. Okay? Coefficient here is 7. So b is equal to 7. And then your c, what is c? c is 12. c equals to 12. So go on and substitute it here and solve. So this is as x is equal to what? Negative 7 plus or minus square root of 7 squared minus 4 multiplied to 1. 1 is what? A, and then multiply to 12. That's what we have at this point. Then divided by what? 2 multiplied to 1. So I've done the substitution. Let us see substitution here. So what I will have is going to give us that x is equals to negative 7 plus or minus square root of 7 squared is 49. Negative 4 times 1, negative 4. Negative 4 times 12 is going to give us negative 48. All over 2 times 1 is 2. So we're still in the process of simplifying this. At this point, this is going to give us that x is equals to negative 7 plus or minus square root of 1 over 2. Yeah, because 49 minus 48 will give us what? 1. Now that we've gotten to this extent, what can we do? Well, let me clean this up and then we finish up here. To finish up here is quite easy. Since we're having a positive and negative value here, plus and minus value, it simply means that this implies that x is equals to negative 7 plus, examine the one of plus square root of 1 is equals to 1 all over 2. Or that x is equals to negative 7, then examine the one of negative. That's the reason why you have plus or minus value. You find for the plus, when you replace it with plus, you solve and you divide and get your answer, and also you replace with minus. So we've separated it to do that. So this is going to give us x equals to negative 7, negative 1. Or examine negative, all over what? 2. So what does it imply? It implies that for here, this same thing as what? Negative 1 plus 6 will give us what? Negative 6. Negative 7 plus 1, sorry. Negative 7 plus 1 will give us negative 6. Negative 6 divided by 2 is going to give us negative 3. Here again, negative 8, negative 7 minus 1, or minus 7 minus 1 is going to give us minus 8 over 2. And that's going to give us minus 4. This implies that our x is equal to negative 4 over negative 3. That is the value of the x that will satisfy this given expression. That is, if you simplify the left hand side, it's going to give you, or you're going to be left with 1 over 2. Try that and let me hear your thought in the comment section. Substitute the value of x here to be either negative 4 or negative 3. And let's see where that leads us, or what you get. Do you have 1 over 2 in the end when you simplify? So we've come to the end of today's section. I hope you now know how to solve logarithm that involves both linear equation and the quadratic equation. We took time to explain and storytelling type of solving in mathematics to make sure they understand this concept. I did not skip steps. I wrote it down and followed along with you so that you'll be able to solve it. And if you have any question or anything you want to say, please in the comment section. Please let me know in the comment section. If you want to contact me, you can also contact me on TikTok. My handle is at Uncle Sam 160. And you can also contact me on Facebook. I'm on Facebook and Instagram as Uncle Sam Online Tutorial. That is the name of this YouTube channel. Please reach out to me if you have anything you want to discuss. Thank you for joining today's class. See you next time.